So I'm going to talk a little bit about artificial intelligence, and because I came from an academic background, I'm going to get really technical, really deep, and really quick. So let's go through the agenda. What is AI? A little historical perspective. What's the difference between AI and human intelligence? There are different types of AI, so we're going to talk about that. Machine learning, neural nets, ecosystems, real-world applications, ethics. We've got to talk about ethics, AI and Creatio, future trends, and then we can have questions. No, I'm joking. You can have questions anytime. So what's AI? It's a term that actually got coined in the 50s, and really what it is the artificial intelligence. It means that human intelligence produced by a computer or a system, and it falls in the categories of learning, reasoning, problem solving, perception, natural language, and decision making. And it's all based on a concept, and I'm going to go historical, by Alan Turing, his Turing machine, when he came up with the concept of, hey, I got a box here, and I can ask the box questions and it'll respond. And if I can't tell whether it's a computer or it's a person, then I've succeeded at artificial intelligence. And then that information got taken up, his research got taken up by Dartmouth, and they had a workshop, and that's where they actually coined the term, but it was all based on Alan Turing's the guy, by the way, who broke the Nazi code in World War II. Anyway, then you got a bunch of people doing a bunch of different research in the 60s. So the biggest challenge to AI has been not enough computing power. They've had the technology they're implementing now is stuff they designed as long as 40 years ago, but just never had the processing power to do it. I remember working on a project in the 70s with the city of Chicago to predict traffic flow using AI. And it took us more time to predict traffic flow than to just have a car drive up and down the expressway and call in where it's at. So it was, it took a lot of computing power. But then in the late 70s, you got a bunch of symbolic AIs. Expert systems came out. The one that I worked on two. One was an X-ray reading, looked for strokes. It took an X-ray and looked for strokes. And it was not as accurate as an expert in the field, but it was more accurate than an emergency room doctor. And so what they ended up doing was deploying this technology. I think it was, I'm trying to remember the company, it wasn't Xerox, Siemens. They started deploying this technology in like rural hospitals so that they could read the X-ray and say, you need to get this guy treatment or not, because it was about 85% accurate, where a expert in the industry, a professional doctor whose specialty was strokes, they were like 93% accurate, but the guy working in the emergency room was only like 70% accurate. So they went through and we worked on that project, and then I worked on a project for AT&T to actually read notes that people were typing into computers. This was before we talked. There wasn't internet in those days. Actually, technically, I think there was an internet, but it wasn't called internet. We actually were reading notes and then actually producing solutions back in a weird programming language. In the 80s, we had neural nets, and then there was the dark period, because nothing could actually get done. They figured out how to theoretically do this, but it wasn't possible to build it. They tried, this is about the time the internet started coming out. The government tried to connect a bunch of computers across the world in DARPANET. But that was really do a lot of research around neural nets. And then you got theories behind machine learning and data-driven. And this is all stuff is really new. 15, we started talking about the ethics of computers, and we'll talk about that a little bit. So what's the difference? Well, the major difference is that we learn really well. We're learning machines in general, and we're highly adaptable, and we have broad capabilities. But computers, they're only bound by their programming, so they can learn a lot very deep, but it's bound. And the speed, computers beat us hands down, but we're really good at decision making. For some reason, we don't have to go through all the analytical steps to make a decision. A lot of times you'll make a decision, it's based on feel, right? But that's not really feel. You're doing a bunch of analytic processing, which they're trying to, by the way, that's how neural nets work too, by the way. We'll get to that later. There is no emotion in a decision made by a computer. There's a lot of emotion and empathy when we make decisions. So again, big difference. Now, what they're trying to do, and you'll see this, is a lot of places, they're trying to create empathy. You'll see these articles and videos on how they are trying to mimic human facial expressions with robots, because people don't like talking to a robot that doesn't have any facial expressions, but that's all artificial. Imaginative, we are very imaginative, and AIs are bound by their knowledge. They can't create anything they haven't seen. So, like if you use DALL-E, I don't know if you're familiar with DALL-E, it's a photo image generating tool. It's great. You could say, show me a green frog, draw me a picture of a green frog on a toadstool done by Salvador Dali. And it will do a pretty good job of doing that. But it can't come up with a creative way of doing it where people can. So that's sort of a different component of this. We're a lot more creative in what we can do. Common sense, we excel at common sense. We understand subtle nuances, or at least some people do. I won't say who. But computers actually can't do that. They struggle with it. And then moral and ethical, we actually have ethics. Again, a lot of us do, have ethics and can make moral and value-based decisions where computers can't. So let's talk about the two different, there's two categories. So the stuff you're seeing in Creatio is all called weak. It doesn't really mean it's weak. It's just narrow, it's narrow focused, trained AI, and the other is general. So the general or strong AI, that's like HAL 9000 or Data or the Terminator. Okay, it can do generalization and reasoning and learning and autonomy, can understand language, it has emotional intelligence, it has creativity and self-awareness. We don't have many systems like that. Plus, do you really want your Creatio saying, I'm sorry, Dave, that opportunity will not close. Okay. So on the weak side, this is where you get the stuff that we're seeing these days. Virtual assistants, chatbots, system recommendations, image recognition, language translation, autonomous vehicles, game playing, we can talk about that, diagnostic systems, spam filters, and trading algorithms. Those are all great examples of the stuff that is narrow. And we're going to talk about, when we talk about narrow, we're going to talk about how to train them for machine learning, and you're going to start to get subtleties. Because the way AI works is you give it a bunch of data, and it figures out the algorithm to generate that data. It's not that you tell it what the algorithm is, it has to figure it out. And so that's where it becomes sort of interesting. So machine learning process at a high level is you got to get your training data correct, you got to train it, you got to define what the features are, that's the type of data it's going to look at. Then you got to have what's called labels, those are the outcome of the data. So a label would be I won a deal. Okay, then you have an evaluation model, and then you have this process called overfitting, underfitting, where you try to tweak it, because a lot of times, and we'll talk about how to solve that, and then you got validation, and then we got to talk about bias and fairness, and then you can deploy. So it's not like I turn it on, because that's not always the best thing. So let's start with some definitions. Machine learning. It focuses on development of algorithms and models for enabling computers to learn and make predictions. That's it. That's the definition. Took that right out of ChatGPT. So I'm sure it's accurate. Or maybe it was Bard. I don't remember which one I took it from. Anyway, what it's really trying to do is create a mathematical model that fits the data, right? And so when they talk about accuracy with AI, it's like, how often does my mathematical model actually fit the real world experience? And then the model keeps getting tweaked over time to be more and more accurate. So you got to use data, And data needs to train and validate and test. And the challenge with the data is that it comes in two formats, structured and unstructured. Structured data is like I say, only look at these fields. Unstructured data says, here's a set of data. It's got everything in it. So the challenge with having training on structured data is you may think the data is relevant, but it might not be. So ideally you want to have unstructured data. But when you process on unstructured data, it takes a lot of time. And I will give you a quick story. We were looking at training starfish to generate maps. And Aaron told me that we look at it unstructured. It was going to take, was it 6 months nonstop for it to actually create the model? Okay, and so we're like, well, now we got to go to a structure. So you see when you're looking at unstructured information, there's a lot more processing power is required. And then the other side of this is that you got to have diverse data. So you got to have all different types of, first of all, data's got to be really clean. If every field needs to be filled in, now I want you to all think CRM and think how often this happens. Okay, but you really have to have data that's representative. You have the data you know the outcome of. The data has to be completely accurate, and it has to be of a diverse population. That's the best way to train. Otherwise, you're going to introduce bias. Two forms of training: supervised. Supervised is where I say, look at all this data, and here's the outcome. So unsupervised is, here's all the data, you figure out the relationships and patterns. Now, we worked with a company, I don't know, maybe like 5 years ago, that was going to was doing surveying, medical surveys. And they used an AI to help figure out what questions to ask. And one of the things they found was that people weren't taking their surveys because it was just way too many questions. It would be all text-based. So you'd get this text, oh, thanks for visiting the doctor, click this link and take our simple survey, and then 20 pages later, you'd stop taking the test, right? I mean, it's one of those things. So, but they use an AI to process the data, and one of the things they found is that you don't give me a 5 if you have a hard time parking, or that you spend too much time in the waiting room. So they were able to use the AI to deduce things and then take out questions. I don't have to ask them how their parking was, because I know if they give me a high rating on everything and they give me a low overall rating, they had a hard time parking or they waited too long. Okay? And so that's a case where they were using unstructured data when they did the analysis, because they didn't tell it what questions to look at. They just wanted to get, its goal was just to eliminate questions. And so labels are the next. What?
Were they just looking for relationships?
Yeah, they look for relationships between the overall outcomes of every answer. And what they found was that there was a super high correlation between not finding a parking spot and getting a good score. So why ask that question? And so that is a good example of how one can use an AI. Features. Features are the data you use to make the prediction. So if you're doing supervised, the features are the names of the attributes that you're pulling in. And then labels is the outcome. So here's an email that's spam. Here's an email that's not spam. So you give it a set of emails that are spam and not spam, and you tell it this is spam or this is not spam, and eventually it sees patterns and learns the difference between the two. I know it's a lot of terminology. Model evaluation is just accuracy. How accurate is this? And overfitting is the case where, hey, I give it a set of data and it comes up for predictions great, and when I turn it on in the real world, it doesn't get the same answers anymore. So you fit it to the set of data so well that and the data's obviously got some problems with it, because now it can't take real world data and make predictions from it. And so that's a real common issue. Underfitting is just the opposite. you don't give it enough fields to look at so it can actually make accurate analysis. And so that's why we do this thing called validation and testing. And the way you do that is real simple. You get a bunch of data, you divide it in half, you make sure it's clean, and you make sure it's accurate. You give it half of it, let it create its model, and then you give the other half and see if it predicted it the right way. And that's how you can determine the value of your AI, and that's what you should be doing when you turn on AIs. Then you have fairness and bias. It turns out that, we'll talk about ethics in a few minutes, but it turns out that the data has to be diverse for it to be accurate. Otherwise, you get outliers that it can't predict on. And so, like if it's the brother-in-law of the owner of the company you know he's going to buy, you may not want to include them in the data set because it might throw in bias in the actual analysis. Now, hopefully over time it'll take those out, but you've got to have diverse amounts of data. Deployment, obviously that's the goal. At the end of the day, we go through this process so we can deploy it. And examples, I found fraud detection, next best activity. We always like to talk about that. Suggested cross-sell, one-loss analysis, self-driving cars, which I can't wait for. And then there's a subfield of machine learning that's based on neural nets. And neural nets, they don't have any restrictions. They're unbounded on their data inputs, and they find relationships, and they're really good for looking at images and stuff like that. And they write scripts for TV shows. Oh, they did that, but they can't anymore. So this is sort of how it works. You have an input layer. That's what this is. And then you have a set of what's called hidden layers, where they build relationships up. So the first thing that's doing is looking at all edges. And it's collecting a set of edges. And it's taking points in the original image and linking it, neural net, making a net to each of those edges. And then it assembles edges into components of a face. Okay? And every edge that's taken will now point to that, making a network of more connections. And then from that, it'll simulate faces. And then it'll take all those things, and that's how it'll recognize a face. Because it's taken one face, but it really doesn't take one face, it takes millions of faces, and breaks it into little pieces, and then reassembles them to make all possible faces. So anything that looks like a face will fall into one of these categories. Then when it sees your face, it does the same thing. It says, is this a human or not? Let me look at my network of faces. Does it look like something I already have? And if the answer is yes, then it's true. And how do we use this? Image recognition. Like when you post your, so first of all, Facebook makes their money by selling targeted advertising, right? That's where they make their money.
Not
and
for my dad's post.
Yeah, right. Not by your dad's post, no. But if you wanted to find people who drink sugary drinks, smoke cigars, and golf, if you have enough pictures out there, Facebook will find that because it's scanning every image you have. And if it sees enough photos with you and a cigar in your hand, it marks in your data file that you have a smoked cigars. If it sees with a can of Coke in the background, it knows you like Coke. Okay, they're building that profile for every time you put a picture up. They are like the number one, them and Google are 1 and 2 in image recognition right now. They got the best software. But they're doing it to look at what you have, where you're at, what location you are in the world, so that they can build a profile of you. And that's why when you go on vacation, you post a picture on Facebook, and it starts giving you hotel recommendations for Sydney, Australia, it's because of that. Natural language processing, chat box, sentiment analysis. I can give you a great story. I got really upset once. Has anyone been to Charlotte Airport? It's a big U.
Yeah.
And I landed here, and I had to run around because my flight was going to take off any minute to the other side of the U. And I don't run. So it was like a miracle that I got there. And they gave away my seat. And the flight hadn't taken off yet. It was like still boarding. And I'm like, well, you have to be here 20 minutes before the flight. But I was 20 minutes over there, not here. Anyway, I posted some stuff on Twitter. And obviously their sentiment analysis came out, really, I should say X now, right? I think it's X. The sentiment analysis came out. Let's talk about this privately. We can give you an airline credit. I got like $1,000 airline credit for them giving, because I was like their top tier flying too at the time. So, that wasn't a person. There's no way everyone's looking at the world's Twitter feed, right? That was me being really upset at American Airlines, and I didn't even tag them. Didn't have to. I just, American Airlines, blah, blah, blah. Anyway, so natural language processing. Speech recognition and digital assistance and transcription and redaction services. This is going to be really big. All calls are monitored, right? Right? And you're not going to keep a recording. Can't search a recording real easily. So you're going to transcribe it. And if I'm going to transcribe it and put it in, say, Creatio as a note, what if I have my social security number in there? What if I give you my driver's license number while I'm talking to you, or I tell you some, like, oh, my password is password, password #1. Okay, that's got to get redacted out. Okay, and so there are services now that will actually natural language process, take voice, turn it into text, find patterns of things like, well, this sounds like a social security number, this sounds like a phone number, and take it out, put a bracket in, and say phone number, bracket social security number, and you can define the rules in these tools. But there are services that are doing that, so you can still scan the note. Okay, you just can't get any private information, and that sort of makes a lot of sense. Otherwise, why would you want to record that really for training and quality purposes? Next thing is recommendation systems. We've all know Amazon recommends stuff that they make. We just saw that in a lawsuit yesterday. And Netflix is always telling me stuff I think I'd like. I gotta say no. I don't like German movies or something like that. A little bit more. Autonomous vehicles. That was Google. That CAPTCHA stuff. Is this a pedestrian? Click all the pictures where there's a pedestrian. Click all the things where there's a bicycle or a bridge. That wasn't an accident. They're training their cars. Okay. And then healthcare, definitely cool stuff going on in custom medicine and custom diagnostic systems. I had a procedure. Before I got home from the hospital, I got the response back that the doctor had reviewed it and said I was okay. And I'm like, yeah, the AI reviewed it, and the doctor just approved it. Fraud alert and credit risk analysis, and then games like chess and Go. And I don't know, this happened it might have been 10 years ago. There was a neural net built by Google called AlphaGo. I don't know if you guys are familiar with this. It learned Go in about a month and could beat the world's greatest Go player. Okay, which is a really hard game, I guess, to beat it. And then about 2 years later, they made Alpha 2, and Alpha 2 played Go against AlphaGo, and within an hour could beat it because it was a more powerful neural net. And then the same day, it learned chess, it learned checkers, it learned backgammon, and can beat world champions. But it took 1 day to teach it. Now, again, very narrow rules. But they're processing really fast, and there is no structure to it. Understand that there's no structure. So it didn't know the rules of chess. It just looked at chess games and figured out what the rules were, And it came up with, and when it actually played humans, it came up with really unusual things that we would never think of doing as chess moves. And it was overly aggressive on sacrificing pieces, but they still won the game. So, which we wouldn't do, right? You wouldn't sacrifice your queen, right? What's in the ecosystem of AI? 3 things: data, algorithms, and hardware. Now, data has to be highly qualified, non-biased, and that's what you use for making your decision. Algorithms are really mathematical models or pattern matching models or data matching models that are being created by the machine learning process. And then the hardware is, there's 2 things, graphical process. You're seeing like all these things come out with like GPUs in them. They're touting, oh, the iPhone, whatever it is, 15 has 9 GPUs in it. What's a GPU? It's graphical processing a unit. Why are graphical processing units so important? Because they process large sets of data. Okay, this new Mac, it's got 32 GPUs in it. What graphical processing is it going to do? Nothing. It's going to do some of them as graphical processing. Most of it's going to be used for AI and doing pre-processing. Tensor processing units is a Google hardware, and it actually manages the workload of the GPUs efficiently so that it can do high-level parallel processing. So one of the problems always with computing was the ability, until 15 years ago, everything was linear, right? And so you do one operation, one operation, one operation, one operation. And then you went from one operation to a set of operations. I'm going to assume if I got a branch that we're going to go yes and no at the same time and pre-process as much as we can. And then when we know the actual decision, we can just take this path or that path. And I think those were called flops. I think that was the technical term for those. I told you I was going to get deep with technology and buzzwords and stuff. So they need, if I'm doing this branching, I need something to manage that, and that's what Google's big breakthrough to the AI industry was basically that. Now the future is going to be quantum computing. I know everyone's like, what the heck's that? Well, it's computing at an atomic level versus, because I can't remember. I think they're down to like 25 angstroms, which is per wire, but that still requires a lot of atoms, probably like 1,000 or so. And this, if they can make this happen, the processing speed is going to be immense. We're talking about multipliers of 100. Moore's law. You remember Moore's law? Yes. Every year everything doubles, right? Okay. Which it doesn't really.
That's increasing.
18 months, right?
18 months now, yeah. But it was originally every year at one point. It's going to reset Moore's law to everything's doubling every year. What just happened? Someone sent me a team chat or something, right? There we go.
So isn't it bound by how thin the etching on the silicon wafer?
It is, yes, and the number of layers on the silicon layer, because they now have multi-layer silicon. Yeah.
Yeah. So can I?
Yeah, go ahead. Yeah.
Okay, so this is like some cool Star Wars stuff. So my husband works for ASML, and they make the extreme ultraviolet lithography equipment that does the etching on silicon wafers. They sell their large machinery to companies like Intel, IBM. It's a big chip process manufacturer here. And so he was describing that this is all for AI, right? Like, because they're going to end up making these chips that power the computers that run the AI, and they're able to do these etchings currently that are 6 DNA strands wide. That's currently how narrow those etchings are, and they already have the technology that they're working on creating sustainably in the next machine that will only be 3 DNA strands left, right? Moore's law, it's got to double. So if it's doubling the processing power, you're going to reduce by half what it is. And so that's just kind of cool.
Yeah, no, it's
cocktail hour, I'll tell you what
I mean, if you see how they used to do it, right? Like even 20 years ago, there would be an etching that was done using photograph. So they would hit it with photographs through a series of templates like stencils, and then they would put it in a bath, and where it wasn't where the light didn't hit it, it would attract the metal. But those were like really, really wide, and they said, well, how do we make this narrower? And they go, well, maybe we hit it with ultraviolet light. Literally the next step, right? Oh, and that cut the size down, ultraviolet light, because it's a higher bandwidth, so it's shorter wavelength, and therefore shorter. What they were concerned about was it creates a curve, right, where this part is really heavy, but light bends because of gravity very slightly, but enough to screw up the chip. Ultraviolet light being very high frequency, bends less, faster, narrower. That wasn't good enough. We went to lasers. Then we kept working on different types of lasers.
Yes, the light wavelength is now created by turning molten tin into plasma.
Yeah.
And they have a Hubble's, like the quality of the Hubble telescope mirror. They have a mirror in this giant machine that's as big as the building we're in right now. And that mirror reflects that light, and then it goes down all these light tubes to refocus it back down to the
right.
6-day strands.
Yeah, it's like, if you ever want to, it's like really amazing what they do to get down, and then you have to do multi-layers. So that's just one layer, and then you have to figure out how do I get you have to think about it in 3 dimensions, right? You've got one layer here, you got another layer here, but you got to connect something to that other layer. So the whole layout of this stuff is just so interesting. And then now they're producing, chips that I used to have a collection before we moved. My wife made me throw it out. But I had a connection of processors. So I had, like the first Intel 4040 and the first Intel 8080 and the 8088 and the first Pentium, which was like that big. It was all heatsink. If you look at the other side, there's like a little chip about this big, but it generates so much heat. It had a heatsink, and then all the way up till like the Intel Pentium 6, I think, was the last one I kept, and it was always interesting to see. That one was about 1/3 of my baby fingernail, and now they're like micro-sized. It's just amazing stuff. Anyway, real-world applications for CRM. Customer insights and segmentation. So you can use AI to figure out how you want to segment your market, right? That's a real valuable use. We could do that using Creatio. They have a model that would let us do that, and you could sit there and say, I want to get a list of people most likely to get a new car. And you could probably look at data like when did they get a last time they got a car loan and other things like that, and produce that list. Lead scoring and prioritization. Obviously, you can look at the leads coming in historically, how many of those turned to opportunities, and we could easily do lead scoring based on what they're looking for, their buying pattern with us, and other things. Chatbots and virtual assistants. I think the virtual assistant thing, if you haven't, I think it was 2017. If you haven't seen the 2017 Google Kickoff Developers Conference video, you should try to find it. Just search Google chatbots. Let's see. I have it up. I don't want to show it, but wait. See, even I don't remember. So it's called Google Assistant can now make real phone calls. So Google that. You can watch it. This happened a long time ago. Well, in our world, and it actually it orders Chinese food. Had a hard time dealing with the accent, but it was something they were working on. They're trying different things, and it called. They made a hair appointment. It was really, really cool to watch, and to understand how they did it. They put in what we would call pauses in our cadence of speaking when it was doing thinking. So it calls up and says something like, I'm Joan's personal assistant, and she'd like to get a hair appointment at 10 o'clock on Saturday. And the person on the other line goes, 10 o'clock is taken, can you do 11? And instead of having a pause while it looks up the calendar to see if 11's good, it says, give me a second. And that was what it was looking up, and then it says, she can't do 11, but she could do 12. And they made the appointment. And it put it in the calendar. Okay, and that was just literally get an appointment for me for haircut on Saturday. So that type of stuff, that was experimental. It did generate a series of ethical questions, of course, but that type of stuff is really experimental. Was 5 years ago, 6 years ago. So that stuff's ready to come out the door. We're already seeing that a little bit with our phones, but you're going to see more and more of that. And there is a ERP software out there that actually has like an Alexa type component you can have where you can say things like, show me all the customers that are 30 days delinquent, and it'll produce a list. So I thought that's really interesting. Predictive analytics, speech and voice analysis. We talked about transcription already. Personalized recommendations. Again, we can all do these in Creatio. Email marketing optimizations. You can actually analyze who's opening what emails and determine what features of those emails are successful or not. Sales forecasting, social media monitoring, workflow automation. Yes, you can have it create workflows by looking at what activities people are doing. Right? If they're recording all your activities, you can look for a pattern and actually create a workflow. And then customer service chat. Ethics. Okay, first thing, if you have bias in your data, if, for example, you're heavily focused on a particular race, gender, age, you're probably going to get a bad read on other people. So you need to just make sure that when you're looking at feeding it data, you're feeding it data that is representative of the whole population that you want to sell to, right? If you don't want to sell to people under 20, exclude them. Privacy and security. We talked about this. I'm sending stuff up to ChatGPT. I'm sending large data sets. How are they protecting it, right? So that becomes a real issue. And then accountability. So this is something I didn't even know about this until I was doing a little research for this presentation. Can I actually use data that's more than 2 years old and be to train and still support GDPR? Because GDPR says I cannot use that customer data after 2 years. But if I'm training it and I'm using older data, I'm technically violating the GDPR laws. So you've got to start thinking in terms of what are legal rules around data and can I use them to train my AI? And then one of the things everything I've read recommends that what you do is you have ongoing policies to monitor the AI. That you're actually looking at it and validating it every quarterly or annually or monthly or whatever. Because at some point, if it gets a bunch of poor data, it could actually change the algorithm and start miscalculating or mispredicting or future trends. We're just going to see AI in everywhere, basically. Narrower domains, more domains. I just saw, when I was doing my research on this, someone's got a refrigerator that looks at what you put in there and tells you stuff that's about to expire. Okay? Like, okay, if it's a little over. I usually use my nose, but for that. But
My kids would love that.
what?
They come into the fridge like,
Yeah. Just the hardware support for the chips are coming out now that makes AI really practical. The fact that you're going to see more autonomous systems, you're going to see regulations on use of AI. We're already seeing that. Better natural language processing. One of the big issues with AI is accents. AI has a really hard time with natural language processing. It's better, but that's one of the things. If someone has a very strong accent, it has a hard time recognizing the words. More discoveries for medicine. I just watched something where they're reverse engineering diseases that don't affect a large population. There's a lot of money if you're going after diabetes, but if you're going after some really small, one-off disease that only happens to less than 1% of the population. It takes a lot of money to develop that, and that's why the drug costs are so high. And they're using AI to say, okay, this person has to solve this problem, we have to block off this receptor. How do we block off this receptor? Well, we make a chemical process that does this, and then makes another chemical process that does this to get this component, and so on, and it assembles them and then says, is that poison? And if it isn't, you got a medicine. But they can do that. They were talking about like in a week they created a custom drug. Okay, using AI. Better personal assistance, and then AI-generated code, and then when you add quantum computing with AI, you get quantum AI, which is just going to change a lot of things, particularly around creating terminators and stuff like that. Creatio supports these models inside of it. So look up value predictions, numeric predictions, predictive scoring, recommendations, and similar text search. So think about that. I'm sure they're going to have more in the future, but these are very narrow AIs, but they're also easy. With Creatio being very good at making it easy and no code, it would be difficult to build a generalized AI. And so they've taken this approach, which is great because these are things we can use right away, as long as your data's good. And they give you a guide. And I tried to read this. This is online last night. I'm like, well, that's way too complex. But it tells you which one to use to get to certain problem solving. I like using ChatGPT to write simple letters. This is a letter it wrote for me this morning saying, and I gave it, write a letter thanking Mr. Smith for our Zoom meeting on September 12th at 2 p.m. and ask him for a follow-up. And it comes up with a really nice letter that you can then edit. I think it's a little too verbose. I should have done it with Bard. Bard is much more concise in its, but you can write letters with it. Conclusion. All predictions, AI predictions are only as accurate as the data. That you need to pick the right AI approach to get your desired result. It's just not any AI will work. Predictions need to be monitored and validated on a regular basis, and just expect to see more AI in your regular life. And just sort of a note, this was built by Bard, OpenAI, and SlideGo. I didn't actually do any of this stuff. I let the computer do it for me. So, any questions?
Oh, super cool.
Thank you.
It built the whole presentation?
No, I edited it, but it did the outline.
And you said create me a presentation?
What?
You said create me a presentation?
Yeah, I said create me a presentation on AI for introduction.
For AI.
I was very specific, and then I did it across multiple tools, not just one. So I used multiple tools to do it. And I said mash up these two outlines.